Okay, now we're going to take a look at a really useful abstraction that is just great to create and use for your patches to control triggering things from a foot pedal that's hooked up to a MIDI keyboard. So the first thing I'm going to do is create a control in, so CTL in, and one thing to always know is that the sustain pedal is always going to be set to cc64. Always cc64 equals sus pedal. And if I take a look at this, you can see when I'm hitting my sustain pedal, I have two values. I have 0 for off, and I have 127 for on. I have nothing else. So I can use a select. Now I want it to only do something when I hit 127. So I'm going to hit select 127. And I'm holding down the sustain pedal, and it sent out a bang, but only one bang. So that's really nice. So every time I press down the pedal, it sends out one bang through select. And I've got this nice little visual indicator here. Now, how do we count this so we can structure the number of cues in our piece? Well, the really easy way to do that is to use counter. So say I have a grand total of 17 cues in my piece. Here's what's going to happen. I am going to create, I wanted a number box in counter. If I hit the pedal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. It gets all the way up to 17. And then if I hit it again, it goes to 0. That's pretty useful to know. However, the first time I hit it, the very first time when I created the object and opened the patch, I had to hit it and it output 0. That's less great. So what we can do is we can create a initialization, and we're also going to use that to help counter not overcount and restart the patches. And we're going to do that by using a gate object. So gate is going to open and close. If it's open, it's going to let this bang pass through into counter. And if it's closed, it's just not going to work. So how are we going to use that? Well, we're going to use it by hooking it up to counter itself. So the second outlet of counter is the minimum flag, and the third outlet is the maximum flag. That's the one I'm interested in. I'm going to create a toggle and hook it up there. And then we're going to drop the value down on counter to 3. So watch what happens. Get rid of that gate for a second. 1, 2, 3. Again, by recreating it, it had that initial 0. But now I hit 3 and I get the toggle turned on. What can we do with that, I wonder? Well, I will show you what we can do. Let's recreate gate. Now, you're probably saying you can take that output of the toggle and just connect it right into the control inlet of gate, which will open or close the gate. If it receives a 1, it opens it. If it's a 0, it closes it. I could, but there's a little problem there. And that problem is that it is not gonna work like that. Because that means that if I send counter its maximum, then it will open the gate and more stuff will come through. So instead, what I'm going to do is I am going to do a little bit of logic. So exclamation equals means does not equal 1. Is that condition true or not? So does 1 equal 1? No. Does 0 coming out of the toggle equal 1? Or is that not equal to 1? Then the answer is yes, it does not equal 1. Does 1 equal, not equal 1? No, 1 is 1. So it's just inverting the toggle. It's really kind of simple, but also kind of genius. I'm going to use this one to control the gate, and then we'll align that so that it's out of the way, kind of hidden. Next, I need to send a couple of values here. I'm going to use those values to set what is reset counter to number immediately, and to set the initial value that's going into this toggle. So I'm going to use a load mess 0. So that goes into the reset counter. It also goes into the maximum count flag. That means that as soon as the patch is loaded, it does the test. Is 0 not equal to 1? True. 1. Open the gate. 0, 1, 2, or sorry, 1, 2, 3. Boom. There we go. So that has created the ability to get a counter that will only go between specific values and will never overshoot them. And that's just really, really, really useful for all sorts of things. But let's see it in action. Let's change that value on the counter back to 17. So again, I don't care about this 0 value, and I'm just going to deliberately filter it out by using a select object. Of 1 to 17, taking its value from counter. Really, really useful there. With this, say I had a preset object with a bunch of random presets. That's 16. Cool. Or is that 16? How many presets is that? 8 slots times 3 would be 24, actually. All right, so there's up through 17 at the bottom. Now, preset, if it takes a message, will jump to a different value. And you'll be able to see this as it lights up. Let's do 4. All right. So there's 1, 2, 3, which goes to preset 17, and 4, which goes to preset 4. So that is really cool. That's really, really useful. I could have this go to other things as well. I could connect bangs up for 5, 6, 7, and 8. And then let's just end it at 8. So I'm going to get rid of counter 17, and we're going to make that counter 8. Now here's what's going to happen. I keep going. I'm going to restart to 0, 2, 3, 4. Now 5, 6, 7, and 8. Now, if maybe I overshot this or something didn't work, I'm going to create one last bang. I'm going to make this one a bit of a doozy so that we cannot possibly not see it. So I'm going to make the background color red. Blink color is going to be just this awful green. And then I'm going to change the counter value here to 9 so that it's 1 higher than my selector. You know what? Let's do 10 so you'll really see this. So this is going to be my error because it's connected to the outlet of select that says if input doesn't match. So if you see this flashing, we got problems. All right, let's redo that. Oh, it just flashed. And I can also adjust the blink time in milliseconds. It's set to 200. Let's do 500. So we're really going to see that. Okay, 1, 2, 3, 4. All my presets work. Bang 5, bang 6, bang 7, bang 8. Now I should get an error. Oh, I did. And another error. And now the count is over and we can't go back. So we'd have to reset. You'll note that resetting sends a 0 out of counter, which is going to effectively cause an error. So something to be aware of. Another thing that I can do with counter is I can send it messages that will tell it what the next value is going to be. So it will jump to that value immediately. So if I wanted to jump directly to preset 6, I would send it a 5 because it just fired out preset 5, and so the next value is going to be 6. So 5 sets it immediately. So really good to know. You can set the values, but you always want to have it go 1 less than your target, and it will output immediately. That's the important thing to keep in mind. There are also other options with counter that you can play with. It's a really cool object, but this is probably the most useful thing you can have with it, is to set it to count based on the number of items that you have for queues. And we'll look at how to structure queues a little bit using collections.